and a good morning to our friends on the West Coast. On behalf of the SPAR Point Group, I would like to thank LFM for their sponsorship of this event. Next, I'd like to welcome everyone to today's SPAR webinar, The Importance of a Trusted Living Point Cloud, presented by LFM. I'm Higgins, editor for the SPAR Point Group and SPARview, and moderator for this program. Before we start, I'd like to share a few housekeeping items that will help to maximize your enjoyment of today's program. First, to ensure call quality, everyone's line has been muted. We do want the event to be as interactive as possible, so questions for today's presenters can be asked using the Q&A box at any point in the session. This is located on the bottom right-hand side of the webinar console. We will ask these questions during a Q&A session at the end. And if you have questions for the presenters, be sure to use the Q&A box. For non-topic related questions, you can chat with the event host using the chat box, which is located above the Q&A box on the console. To no issues, click on the phone icon, which is located above the chat box for assistance. Finally, should you be disconnected, you can return to the event using the instructions provided in your initial confirmation email. If you continue to experience difficulty, please email info@sparpointgroup.com. And now to today's program. I'd like to start by introducing our speakers from LFM, Gary and Matthew Craig. Gary is a mechanical engineer and began his career as a systems safety engineer, working on projects as diverse as air traffic control systems and nuclear power plants. He has been in 3D laser scanning from its inception in the late 1990s, initially undertaking projects delivering data and 3D models. The groundbreaking work with Volvo in the Netherlands and a huge scanning project for Fluor/TCO in Kazakhstan. Today, he works closely with customers in many industries, helping them to use 3D data capture technology to increase productivity and using their feedback to advance the performance of the innovative LFM software solution. Meg currently holds the position of North America Business Development Manager for LFM Software Limited. He has over 33 years of experience working in and servicing the engineering and construction service market for various industry sectors. For the past 17 years, he has specialized in development and implementation of 3D data capture technologies for engineering and construction companies. He developed proven execution work processes and managed multiple large-scale laser scan projects. He also held positions as a business owner, project manager, office manager, systems analyst, and application programmer. So, Gary and Matthew, welcome, and now I will hand it over to you.
Thanks, Sean. I guys for the length of those bios. That's what happens when you get two people that have been involved in laser scanning for a very, very long time. So slide is the most boring one in the presentation. It's our safe statement. I'm going to tell you lots of nice, exciting things, but it means that we reserve the right to change our minds. But we're going to try to deliver against the things that we'll show in this presentation. So a quick overview of the presentation. So we're going to introduce LFM, and we'll talk a little bit about why people would use a scan. And then we're going to explain our new big idea, talk about Trusted Living Point Cloud, and really drill down into what we mean by the Trusted Living Point Cloud. And the exciting things, which is to look at exploiting the value of this laser scan data set and the Trusted Living Point Cloud. And we want it really to be a dialogue. Even though we've been involved in the industry for a long time, we don't think that we've got all the ideas. So the experience of the people on this webinar to give us the feedback to make sure that we are on the right track and that we want to exploit the value of 3D data capture and the Trusted Living Point Cloud. So, into LFM, and also a quick chat about why people laser scan. We're LFM Software. We're an Aviva Group company. We're based in Manchester in the UK. And as in the bios, we've been involved in laser scanning for around about 18, 19, nearly 20 years. Done projects. Also been involved in the manufacture of the hardware, and most importantly, in the development of 3D data capture software solutions. We now organise ourselves as a data capture centre of excellence, and our real focus is coming up with innovative solutions to work with laser scans. An important thing that we've tried to do over the years is to listen to the feedback of our customers and do solutions that they really will be able to get value from laser scan data. And I'll try and continue in this webinar today is to get that feedback to make sure we're on the right track. So we're very excited about scanning, we're very excited about 3D data capture, and to be able to work with the data in the best way that we can. So, on laser scanning on the web, so laser scanning is without doubt the most efficient way to capture the existing conditions. If we compare laser scanning to traditional ways of capturing information, there's an 80% reduction in data capture costs. That because laser scanning automates the capture process. We have that we put in the field or in a room, we press a button on it, and it very quickly, in a matter of minutes, captures a full 360 by 300 odd degree field of view around the scanner. Good QA and we need good work processes, but the key feature is that we have automated the process. And with automation, laser has become the most affordable way to capture the existing conditions. So hand-built systems in the early days, costing about $250,000, we now have systems in the region of $40,000 for a laser scanner that really does capture the environment in an efficient way. And there are many available laser scanning service providers, survey companies using this technology, so competition out there in the market. So we become more affordable. What we actually do more laser scanning. Why do people laser scan? Well, it's whether your plant, your power station was built many years ago. It might have designed on drawing boards, so your paper information, or you have a more modern plant designed in 3D, and you have an initial 3D model. The plant is going to change constantly throughout its life. So it might be built a long time ago, or it might be built more recently, but the plant itself is going to be continually modified and operated. Laser scan to help us make good decisions. And laser should be part of this process. It's not a magic bullet, it's part of our decision-making process. Because laser 3D data capture gives us a really good overview of the 3D, the real asset. Oh, pressed the wrong button. I don't know how I did that. Use laser scanning. Well, traditionally people have perceived that it's used really for added modifications, for upgrades and repurposing. But we can 3D data capture information to act as a great to visualize the asset, whether it's for maintenance or inspection. And we use it for two other areas where people don't generally perceive that it can be used. So compliance and management. Into compliance and improving operational readiness, we can, during greenfield construction of a plant, the laser scan data to update our design model so that as the plant comes into operation, we've got better quality as-built documentation, and an owner-operator can therefore get to nameplate capacity much sooner. About construction management, an example, owner-operators want to pay at the right time, and contractors want to be paid at the right time. Be able to use laser scanning and data capture as a way to demonstrate the amount of construction progress that we've made. An example of this that I know about is on a construction project, a road construction project in Thailand. The minister responsible for payments had to spend every weekend flying around Thailand in his helicopter, varying how much construction had been done. He uses a laser scanning contractor to scan during the week and that approves payments from his desktop to be able to monitor construction progress during manufacture. What should laser scan? Well, we should laser scan things that are involved in the capital intensive industries, so oil and gas, power, nuclear, but also be big manufacturing plants, it would be hospitals, airports, mining and so on. So anywhere where a large amount of a owner's capital is invested, they need to be able to have good operational reliability of that asset so that they can get their return on their investment. So there are many different areas where we should laser scan. We start to think about doing with the data. So additionally, that what we need to do is turn the laser scan data into a model to realize value from that data. Because they want to improve the ability to manage information, to improve the visualization, and also to add intelligence to that data. And there's no doubt that taking the laser scan data and putting it into a model does that. Problems. So producing a model takes time, money, and in a strange way we're adding uncertainty to that data. As an example, if you have a big process plant that's got lots of old sagging pipes, what's the best way to model those in order to be able to show in a kind of design type model? So our goal is to work with the laser data, reduce the amount of time, cost and uncertainty, and let's try as much as possible to work with the raw laser data direct from the data capture device, from that fantastic machine that's automating the capture process. Our goal and our vision at LFM. We and our customers are already doing this today. We're all using the raw laser scan data as a reference in design packages for reference and revamp, and we're using the laser scan data with the new design model. So either use it as a reference, giving it in 3D context, the data to extract tie-ins, and importantly to crash detect between the point cloud and the design model. So using that raw laser scan data today. And we got quantifiable benefits from that. So customers, for example, at Paragon and Jacobs, have used laser scan data on many projects, and they display some of the quantifiable benefits. So reduction in hookup time on offshore projects, reduction in engineering time, reduction of rework, but importantly, they have to use less offshore visits to get the information to enable them to do their re-projects. And reduction is in the amount of project rework that we get. So Engineers Record have done lots of studies and say that rework can add to about 20% of a total project's value. If we follow build work processes and use data capture in the right way, we can reduce that project rework to less than 1%. So we can make big benefit in terms of revamp projects. For example, here we'll look at this slide again later on in the presentation of using the laser scan data directly in the design environment. What to do is give our customers across the asset lifecycle the ability to work with the data in this kind of format. More of the raw laser scan data across the asset lifecycle. And one, because we've got some good marketing people, but I'm not one of them, we've got a great way to describe this philosophy of working with the raw laser scan data. And we call it, and we've named it, the Trusted Living Point Cloud. And that's what the presentation is going to be about, is about describing what this is, and you can get value from that. Living Point Cloud, we think there are 6 principles that we need to adhere to, and this is where we need your feedback, please. At the end of the webinar, let us know whether you think that we've got these ideas right about how to be able to extract value from the Trusted Living Point Cloud. Being able to work with massive data sets. We maintain the laser scan data as is, so it reflects the as-built condition of the plan. To make the information we're placing into the Trusted Living Point Cloud is verifiable. To be able to access that data whenever we need to. We have great ways of visualizing the laser scan data, organized for the tasks and work that we want to do, and we'll need fantastic tools that can enable us to leverage the value of the laser scan data. So this is the ideas and the principles behind the Trusted Living Point Cloud. I'm going to look at these one in turn, so I'm going to hand you over to Matt Craig in Houston.
Thanks, Gary. So the principle of the Trusted Living Point Cloud is the ability to manage massive data sets of the registered point cloud data from any 3D data capture device. And what this means is, as the asset changes, the need to add and archive point cloud data without disrupting the integrity of the overall point cloud project is critical. This is a fundamental building block of the Trusted Living Point Cloud, and able to manage and maintain an evolving and growing point cloud database. The ability to work with multiple 3D data capture devices not only addresses the growing market of terrestrial laser scanning devices today, also mobile and handheld imaging devices that are becoming more popular and economical than any other future 3D data capture device. Next slide, please. Working with multiple laser scan data sets within the Trusted Living Point Cloud that uses the same survey control as is a reference we refer to as data fusion, as well as the integration of the 3D model. There's a distinct difference in the 3D point cloud data between devices. It's just 3D data, and that's the idea. Keep it simple. In displayed here, which is a data set of a plant site provided by SPAR Engineering, emphasizes the functionality in mobile 3D data collection to rapidly capture the overall site, which can be used to fuse together with terrestrial laser scan data. This is the Trusted Living Point Cloud with the ability to choose the 3D data capture device that fits their as-is data solution requirements. Back over to you, Gary.
I've got a little bit more around adding different devices in the second. The first principle is massive data sets, and the second principle is to be able to maintain the laser scan data as is. It's that as the plant evolves and changes, we can update the laser scan data set and show the current condition. To be able to show the latest revision, also need to be able to maintain the data as the asset evolves. this is particularly important when we're considering offshore platforms. We need to be able to scroll backwards and forwards throughout the data set to show the amount, for example, of loading that's based on that platform over time. And the Pointcloud data is a good way to be able to demonstrate and verify that. What we need to be able to do is we need to be able to compare Pointcloud to Pointcloud and Pointcloud to model. So again, we can see the history of the plant as it evolves and be able to show variations, for example, on these phase sagging pipes again, or as the structure changes, but also to be able to see if we have a new design evolving in the 3D model space, how that compares to the Pointcloud. So let's look at this process of demolition, and that's the ability to go in to a particular plant, to define a volume of interest, so in this case, a pump, to be able to isolate that, and identify which particular part of the data set we're working with, and then if this pump is going to be removed from the real live condition of the asset, we need to be able to take that pump out there. So you can see the quality of the laser scan data, the way we're working with it, and the ability to be able to remove objects from the point cloud as the data set evolves. And to be able to, as we class detect and so on, we're not going to identify any false clashes. And then in terms of keeping the laser scan data set as is, we start to work with the handheld devices that Matt just touched upon. And he'd be flying around in our office in Manchester with $4,000 dock system. And we've all captured our famous pump that we just demolished using handheld system, and we're able to integrate this into the overall master data set. Set an idea as an owner-operator go forward, you can pay to have a dedicated laser scanning service provider capture your entire asset using terrestrial or kinematic scanning. Your own owner-operators, your own operators, can then work with the handheld systems, quickly capture things as things change, and integrate that into that overall data set. So, principle number 2 is maintain the laser scan data set as is. Back to Matt.
Okay, Gary. So the third principle of the Trusted Living Point Cloud is verifiable. And what things is having the tools necessary for the user to have the ability to easily validate the accuracy of add intelligence to the Trusted Living Point Cloud in an easily organized manner. Next slide, please. So, accuracy of the Trusted Living Point Cloud is crucial to companies using information in support of ongoing engineering and construction projects. The point cloud data is used as a basis of design or reference for ongoing construction activities. And tools working with the Trusted Cloud must be able to accurately register the laser scan data to survey control, accuracy reports, and visualize registration networks to ensure verifiable results. Slide, please. Another of the Trusted Living Point Cloud being verifiable is the ability to easily add and view intelligent information in an organized manner, and we'll talk about this a little bit later on. These can be added manually by importing spread information. Then can be reference tagged ID information, documents, or links to sites. All be easily organized in a hierarchical data structure that allows users to quickly search for the information that they've placed in there. Next, please. So the videos will demonstrate the process of using the bubble view as the vehicle to 3D markup freestyle. You can see the user selects a point command from the 3D markup menu and places it in the reference point identified in the bubble view. This is scale to the user's desired size. After the dialog box appears that will allow the user to add text and URL. this information to the 3D markup. The next example demonstrates the user selecting the cylinder command from the 3D markup menu. The user selects 2 points along the surface of the tower and then selects a scaling tool to adjust the size of the cylinder. Afterwards, the dialog box appears and it goes through the same process to add text, add tags, and URLs to the 3D markup, as stated in a dialog box. So actually putting in a URL at this time. This example demonstrates the user selecting the box command from the 3D markup menu. The user selects a point in the bubble, which centers a default box with grip handles, which to scale the box. Afterwards, the dialog box appears, and again goes through the same process of add text, tags, and URLs to the 3D markup. And it's a simple process, and as you can see over in the left column, that in the hierarchical data structure. And a point to be made is that when the 3D markups are made in one bubble, they're viewable in other bubbles.
Thanks. So, we organised and added intelligence to the data, and now what we need to do as part of our Trusted Living Point Cloud is to access this information in the right place. That involves accessing it in the right location, whether it's the office, the field, or on the move, on a particular device, a desktop, a tablet, or maybe a new fancy iPhone. Also in various applications, whether design, review, or asset management. For this, in use of our new product called LFM NetView, NetView 4, which is to access the information wherever and whenever we need to. So it's a tablet-enabled product. It's a plug-in free product, so it just works directly in the web browser. It's cloud-enabled, whether it's public, your company's private cloud, or a normal kind of server implementation. It has fantastic online or offline mode, so work in areas where you've got no good internet connection. It's possible to take the data offline on your tablet, work it remotely, and then when you've finished, go back and synchronize the data. It's got a link to the master server data set. So talk about the Trusted Living Point Cloud and being able to keep it as is, to be able to work with massive data sets and so on. NetView is a window onto that master data set. It's got links into simple URLs and documents, and when you need it to, it can fulfill a role in terms of handling the laser scan data as part of a larger overall asset management solution, for example, integrated in something such as a VivaNet IntelliLaser, where you need ways into other applications such as Maximo and SAP. NetView. As we on this simple, we can interface between the guys in the office, working with the people in the field, and they're both accessing the same data set. Now, I'd like to give you a live demo of this. So just to explain what we're doing, I'm presenting from Manchester. The is from a facility in Houston, and the data is being hosted in a Microsoft Azure data center. So, do a live demo. You see here that we have a key plan that's been automatically generated by slicing through the data. You can see I have lots of circles which indicate where I have the laser scans. So I'll just click on a scan, and it's now brought very quickly the data from the data center in Europe. And you see that as I scroll around, I have the key plan at the bottom integrated within the bubble view that shows me what I'm looking at. So as expect from this kind of view tool, the ability to go in and make measurements. So this is tablet enabled. It's all very convenient to work with touch. I'm just running it on a laptop at the moment. But we can select a point, next to the master LFM server data set, and gives us the information back from the master data set. Can do go back to the key plan, more detail, and you can see that as Matt showed you during the presentation, we go in and add intelligence to the laser scan data. So I'll show you two kind of example tasks that we could do. So you'll find things that I need to inspect. I just type in the keyword, and I mean an object that I need to go and inspect. It shows me in the key plan where that is, and I can then go and load up the scan information that's particularly relevant to that object. I'll click on it. I can now see I've got a fire extinguisher. If I'm at an inspection process, and I can say in 2015, and I submit that label back to the master data set. So the user that logs in now this information either on a tablet or in the office environment will see the markup that I've just put in. 3D labels, we can see we've got, I'll just clear that. We hierarchy, so I can go in and I can look at my piping group. I've got some valves in that piping group. I can go and look at a particular object. I can see I need to load a different scan. I'll look at more detail. So we've got URLs now that we can click on to. So if I go and click on this particular valve, and click on valve, it's giving about that particular valve. If I go and click and find out a bit more information, I can see the description of the pipe of the valve itself, and you can see that if I want to have more data, I can just click on that. So we're using the laser scan data as our view on the 3D asset, so we can go in and work with that. We've added intelligence, so we're now consuming that in the data set. Switch back to the presentation.
Thank you. An item regarding the accessibility of the Trusted Living Pointcloud is being able to work with the point data along with industry standard or leading design applications with no modification of the cloud data going from one design application to another. Interoperability. This example, as you can see, the Trusted Living Pointcloud integrated with Bentley MicroStation, NRF Smart 3D, AutoCAD, and the VMS. But there are many other applications that the Trusted Living Pointcloud can be integrated with. Back over to Gary.
Thanks, Matt. So now on to principle 5 of 6. So hang in there, we've nearly got to the end. This is a really exciting one for me. So what we're going to do is to look at the optimum visualization for the task. So these laser scanners give us fantastic quality data, and what we need to be able to do is be able to present that information to the user in the best way possible. So up until now, people have been used to working with the Pointcloud. The LFM customers have been used to working with the Bubble View, which integrate completely with the 3D Pointcloud. So we can switch between Pointcloud and Bubble View seamlessly. Everyone knows which bubble it comes from and vice versa. What we do is a new way of working with the data. So everybody loves the Bubble View, but a few small issues with the Bubble View. One is the trapped at the viewpoint that the scanner saw, and that's why we get that fantastic quality information. But ideally, what we want to be able to do is have the same quality of visualization that we have with the bubble view, but to be able to fly around anywhere within the laser scan data set. So like our goldfish, we want to be able to escape from the bubble, but every now and again, we might just pop back into the bowl or into the bubble so we get that super read again. And we also need to be able to generate bubble views or bubble view type quality handheld and kinematic devices. So clever guys in Manchester, which is not one of me, have done some work and we've patented some super duper technologies that we're going to show a lot more at SPAR National at the end of this month. I'll introduce to you now the hyper bubble. So a data set that we've been familiar with already in the presentation from the Eaton Centre in Houston, and we're at the scanner viewpoint. We're in centre, the area where the scanner saw. What we'll be able to do is to go for a walk through the data set. So the bubble, we're able to move anywhere throughout the 3D data. So you see the areas at the bottom of the scans are where the scans were actually taken from, but we're just able to move seamlessly through that data. We can hyperbubble in grayscale or colour if that's information, and we can walk through the planet. It's not only we're showing you an AVI, but this is being done online using the graphics cards. We're working on the GPU, and when we can stop and look in more detail in this kind of hyperbubble quality rendering at things that are of interest. If you're top of the screen, you'll see the hyperbubble in Magic. So where we've got low quality and low density of data, we're not able to invent information, so we get a few triangles, a bit of triangulation breaking down. Where we have good quality data, the hyperbubble is a fantastic way to look at the data set. Draw points, design application within our normal applications or within review applications, we're able to draw the hyperbubble. We measure against the hyperbubble, we can demolish, we can clash, and so on. So it's a new way to work with the laser scan data set. You can count navigating throughout the plan. I said before, like our goldfish, every now and again we might want to jump back to the security and also very good rendering quality of the regular bubble view. And we'll get to a position we can park and we can look at the data in the regular bubble view. So we have a way to render and work with the laser scan data set. We have the normal point cloud, we have the bubble view, and we have the hyperbubble. And for users to decide which particular way to visualize the data they want to choose depending on the task that they're going to work with. Okay, Matt.
Okay, Gary. So this is to the sixth and final principle is providing optimum tools for the task. Now, we have about principles of the Trusted Living Point Cloud, and these principles all bring value to the user. Finding and developing differentiating tools for specific tasks will be additional value to the Trusted Living Point Cloud. We've already discussed three of these tools already, which demolition, fast tagging, and the hyperbubble. Other tools like modeling, bubble measurements, and clash already exist, but adjustments will be made to these tools as required by the user community. New for the task will be developed as a user community and as market demand. As the tools increase, the need for a robust API to allow third-party development will also be made available in the future. So let's look at a few of these optimum tools for tests. Next slide, please. So this video demonstrates the modeling tools that were developed to work with the Trusted Living Point Cloud. In this example, as you see, the laser modeling application using tools to model structural members from the bubble view, and then extracting intelligent information from PDM's catalogs that were imported into the system. Tools were developed to work with numerous structural members' shapes, and additional tools were developed to clean up structural connections as demonstrated in the 3D view you see here. For example, we see the same process for modeling pipe runs and extracting intelligent information from PDMS catalogs imported into the system. Additional tools were developed to place piping components such as connections, flanges, and valves, just to name a few. And see where also using 3D data to add the piping components such as T-connections, so it has methods to physically automate the cleanup process. In the sample, this video demonstrates the ability to export intelligence with the model. In this example, we see the user exporting to a PML file, which is imported directly into the Viva PDMS with all the associated intelligence. Next slide. In review that Gary showed earlier, demonstrating the interactive class feature of the Living Point Cloud. In this example, we see the bubble view interacting with the Viva E3D modeling application, where you can see the new model piping interfering with the as-is condition, and this item being highlighted in red. And the user can make real-time modifications to the design model to the class by adjusting the pipe run and then moving the valve into a new location, thereby avoiding potential rework in the field. This being in design application and using the Trusted Living Point Cloud testing condition model, and not to recreate an as-built CAD model, which could add additional time and cost to the project. Next slide. Another tool for the task that has been requested by the user community is the ability to produce drawings, which show the new 3D design model of Trusted Living Point Cloud, thereby eliminating the need to produce an as-built CAD model for the purpose of creating document deliverables. Next slide. You can see that the Trusted Living Point Cloud is being integrated with the E3D drawing application, which will be available later this year. Users will be able to add dimensions between CAD geometry and the Trusted Living Point Cloud. Principle number 4, this Optima tool, as with other tools developed for the Trusted Living Point Cloud, will be available for design applications.
So, last 2 slides. We tried to explain to you is a little bit about the background of LFM. I'm involved in this laser scanning business for quite a while, and by listening to our customers, we've been able to come up with some good, compelling solutions. We talked about the Trusted Living Point Cloud. So the big idea is that you try to use the scan data direct from the automatic capture device as much as possible. In order to be able to do that, we need to be able to work with massive data sets. These data sets are not getting smaller, they're getting bigger all the time. We've got EC customers that have been on a site for an owner-operator for 5 years, scanning continually, and bring more and more data in there. We need to be able to keep the laser scan data set as is. So we don't want to generate a new problem of how on earth do we know what the current version of laser scan data is available. We need to be able to continually update and maintain that. When we're getting data in, we need to be able to verify its quality. We need to be able to allow users to access that information wherever they need to, in terms of device, location, and application. people really like point clouds. Some people really like bubble views. We also need to keep thinking about the best way to visualize the laser scan data. And by introducing the hyperbubble, we take it to a new level. Any existing data set with the right quality and resolution of information, we will be able to produce hyperbubbles from it. A point that Matt talked about, optimum tools for the task. You need to have great ways to find the center line of steel, the center line of a pipe, to be able to demolish, to be able to, if you need to build a model, great ways to turn the point cloud data into a model. So solutions, you can quickly capture your asset, whether offshore platform, a nuclear power station, a hospital or an airport. You can get access to the trusted living point cloud on demand, wherever and whenever you need it. You can add engineers to the scans, and the goal is to enable you to make good decisions, whether it's in terms of operations or whether it's design decisions if you're doing a revamp. So we'll listen to you to understand you think that we've got the right ideas about the trusted living point cloud, and we'd like to work with you in the future. So to Sean.
Thank you, Matt. We have a few questions to get started. The first one is, you talk about using handheld scanners to refresh existing data sets to terrestrial scanners. How cool is this in reality, and have you seen any examples of this?
So Matt, if that's all right with you, it's very practical. I think if you just consider the presentation that we went through, we showed how we demolished a pump, we gone in with the handheld scanners and with a handheld scanner and then integrated those two data sets. Lots of our engineering customers that got in-house scanning capability, they started to add the handheld systems to their portfolio, to their toolbox, and they're trying to do exactly what we would propose, which is to scan with kinematic or terrestrial scanners and to use the handheld devices to make changes as things evolve over time.
I comment on that as well. The only thing that I want to make sure you understand is that these are all tools, and when working with tools, you really do need to have a well-defined work process. And we have proven this. Some of our partners who worked in this area will tell you that a process is needed. So in other words, you just can't automatically assume that everything is going to work perfectly. This will work, but the process has to be implemented as a result of that. And when followed, you do have success.
So our next question is, it's to use raw user data directly from the scanner, but when will you choose to build a model?
Do you hear that one, Gary?
Yeah, Matt.
Okay. So the interesting information with regards to the 3D model, what is the model used for? Most applications from the engineering and construction side of the business, it's being used to create a model for clash detection or design verification. And where the point cloud data can actually, the trusted living point can actually be used for this, and so there's no need. That management tool, as an asset management tool, a model would actually be useful to the owner-operators as they're updating. But as illustrated with the fast tagging and tagging the information in the point cloud, it gives the owner-operator the flexibility to model as needed, not model everything as required. Because when you do model, you don't get 100% of the model. So it's kind of a hybrid environment where you have a 3D model on an as-needed basis with the point cloud information that is everything that's captured.
Question we have, you showed a slide where you were talking about the interoperability of the software. Somebody wants to know specifically if the software also integrates with Autodesk Revit.
Matt. So the simple answer to your question is yes, it does integrate with Autodesk Revit. Within Autodesk products, they've got their recap plugin, and the user needs to work how to differentiate where should I use LFM and where I use recap. So from my perspective, we've talked about Trusted Living Pointcloud, being able to keep the laser scan data set as is. So I think we offer a lot of value in a Revit application where you're working with a big data set, where you need to make sure that it's the current version. And so I think also the bubble that showed before, I think it's going to add a lot of value to the Revit application. So the simple answer is yes, we can bring the point cloud into it.
Point out is Gary just mentioned we do have the ability to export the Living Point Cloud in recap format as well.
So another question we have, somebody else, the hyperbubble looks great, but what exactly can you do with it?
Good question, I think. Yeah, hyperbubble does look great, and what we do with it is, I've tried to kind of present this in the presentation, is wherever we can draw point out today, we'll be draw hyperbubbles to show that at SPAR when we've got this product out. So you can demolish the data, you can clash in it, you can find the center line of a pipe, you can identify tie-ins, you can fly through it in a review application. So basically, when you draw points and the things you can do with points today, you will be able to do with a hyperbubble in the future.
The next question, I guess, would be, when will the hyperbubble be available?
Okay, so our PD guys are working on that now. We've obviously got some beta software out with some of our value-added resellers, and they're playing with that. Going to do a lot of promotion and demonstration of the hyperbubble at SPAR International in Houston at the end of the month. It will be in our released product in July, so in the middle of the summer. So SPAR International will be asking for people that want to be beta customers for hyperbubble to come forward, and we'll start to work with them so that they can get the best experience from the hyperbubble.
At one point in the presentation, you described automatically adding intelligence to the laser scan data. Can you tell us what type of data sets have tag lists and XYZ information and so on?
Yes. So one example of this would be, well, for example, one way we think this could work is we can import a tag list and a set of XYZ coordinates and automatically put the tag information direct in the bubble views. And as we said in the presentation, as it's a 3D markup, every bubble view that sees that object will automatically be propagated. So an example where we could use this is if a customer has a design model that they're not completely comfortable in the quality of, we could start to quickly burn all that tag information into the laser scan data. Or something like inspection isometrics that they've been working with for a long time, they would be able to use the inspection isometric information to quickly hotspot the laser scan data. So they can go from some kind of non-really 3D information into some valuable 3D data at the press of a button.
So, question, one of the major themes of your presentation was about maintaining the history of the data as the asset evolves. Can you talk more about why you think this is important?
Matt?
Well, as you know, the asset of a facility, whether it be a building, a plant, or it'll fluctuate over time. Some assets actually change on a daily basis as well as on a monthly basis. Information that's continually updating. As the history goes on, it's usually scan data for the Pointcloud data has always been in support of ongoing project execution work. We're starting to see a shift in that philosophy where owners are becoming more interested in maintaining the asset and use this information on an ongoing basis. To have updated information as it evolves. They physically rescan everything every time is always a snapshot in time. And you use some of the information with the facility, which helps reduce the cost of actually the scan exercise. Now, we'll say, well, it's no longer a cost because the cost is very economical. But what it does do, it forces individuals to maintain the control of where the asset is. So if you localize it, you ensure that the data is matching up with each other. And that's been the challenge in the past, the survey information when people go out and execute projects where survey control doesn't match up from one project to the next. So from an operator's perspective, it makes very good sense to have this information, but also the ability to physically archive as needed, so it no longer, if it doesn't represent that anymore. So hopefully that will help answer the question.
For about one more question, someone asks, is NetView only on the cloud? If so, do you see that as a barrier to adoption?
Take that one. So the answer is we have three options for NetView. One is on cloud, so using Microsoft Azure to host the data. The other one is to install the software on the client's cloud, and then the third one is to kind of use a normal server instance. So the answer is I think we've got it covered. So some vendors are starting to move away from giving flexibility for customers to be able to work the environment that they want. So we haven't done that. We're giving the customer flexibility to host the data where they want. In the future, customers are going to become more and more acceptable to work with data on the cloud. We're starting to see that as we roll NetView out, great adoption by our customer base so far. So at the moment, we think to have those three deployment options. At the moment, we're seeing a good acceptance of a cloud-based solution, and I think that's only going to grow.
Well, that's about all the time we have for questions. So thanks, Gary and Matt, for a fascinating look at the Pointcloud. And thanks to LFM for their sponsorship of today's event. Before we sign off, I have a few remaining bits of business. Stay tuned for a follow-up email on accessing the on-demand version of today's program. I'm always eager to receive your feedback, so please complete the short survey that will appear when you log out. If you have questions or comments, feel free to contact me directly, s@divcom.com. The email address should be under my pic on your screen. And if you're not already signed up for SPAR International, happening starting March 30th in Houston, then you probably should be. LFM will be there, as will all the latest technologies, solutions, tips, and tricks for the 3 professional. Check out the website at sparpointgroup.com/international. So to you for taking time to attend today's SPAR webinar, and have a great rest of the day.